Hello everyone. What is a factorial design? This is what we are going to see today's video. If you have not subscribed to my channel, kindly do it. We'll quickly move on to the next slide. It will show you what is called a factorial design. Here we are going to study about 2 power k factorial designs. It is also called as 2k factorial designs. Here we are going to study about the 2 power 2 factorial design, and the coming video we are going to see 2 cube factorial designs. So we'll see what is it, where we have to use using an example here. So before going on to that factorial design, we have to understand what is called an optimization. Okay, so what is to be optimized, why we need this. So what is this optimization is about, we are going to see today. So it's a process of finding the best way. So whenever we do a research, or whenever we are preparing, see for example in pharmaceutical industry, we are going to prepare a tablet. So we'll be using some catalyst, we are using some solvent, etc. So what is the best way in which we are using the existing resources into account all the factors that influence decision in any experiment to maximize the product, okay, maximize the profit. So we are going to study, that's called the optimization. Suppose there is a factor A, there is a factor B, there is a factor C. By adjusting these levels, how can I get the optimized solution? That is what I'm going to see it as the optimization. Okay, so choosing the best from set of alternatives to obtain optimum formulations. That is what is that. Okay, suppose there are trial 1, trial 2, trial 3. Which trial has given my best result? That is what I'm going to take it. That's called the optimization here. Okay, so for example, we'll take a pharmaceutical industry. There, a pharmacist generally conduct experiments by series of logical steps here. So he's trying to adjust some levels so that he will get the optimized solution. This is what is given as the optimization for us. Okay, so see, he used to control the variables. Okay, there are variables. He used to control the variables either by increasing it or by decreasing the variable levels. So we will be getting a product which gives us the most profitable one. That's called the optimization solution. Okay, so in factorial design, see, it enables the researchers to study and understand how interventions interact with this. See, for example, there is a factor A, there's a factor B, how these two interact with each other. That is what will be done in factorial designs here. Okay, so we'll take a simple example to find out what is factorial design here. So first we'll see what is a factorial design. Okay, it's a type of research methodology. So it is nothing but a method where we are using it in research that will allow a researcher to investigate the main and interactive effects. See, for example, there is a factor A, there is a factor B. It is directly influenced the variable. That's what we are finding out. Otherwise, there is any intervention between these two. That's also I am going to study. That is called the factorial design is about. Okay, so now 2 or more outcome variables. See, for example, so we'll be having an outcome variable here. Okay, so it is an important method to determine the effects of multiple variables on a response. See, whatever we get a response, that usually I'll call it as an yield. So whether it is a crop, whether it is a experiment, whether it is a product developed by pharmaceutical industry, we usually call it as yield. Okay, right. So now it is a cost-effective way because it just saves time and energy and money for us when we use it. Okay, cost-effective way to examine different interventions simultaneously. So without exactly conducting the experiment, we can do this. So it is the only design that enables researchers to study and understand how interventions interact with each other. That's what we are going to see in the factorial design. Okay, so it can be analyzed using ANOVA. So we'll be doing ANOVA in this first example. In the next video to come, we'll be using regression analysis, how to do this factorial design, how to analyze this factorial design using regression analysis. For time being, we'll be doing it how to analyze using ANOVA. That's what we are going to study in this example here. Okay, so for example, I'm going to give one example here. See, for example, take this guy. Okay, so by seeing this picture itself, you can see he just wanted to reduce his weight. Okay, so he just wanted to reduce his weight. So he approached some researcher. Okay, so now after 1 year of some treatment or some regime, they are giving it, so that this guy has become like this. Okay, so this is 1 year transformations. Okay, so in 1 year he's becoming like this. So now what is the treatment they have given? They wanted to study, see what is the relationship between this to this. Okay, so what has helped him? They wanted to do it. Okay, so first of all, so this guy has been given, see, a pill. Okay, a pill to reduce the, okay, diet pill. Okay, a diet pill is taking, and then he's also given a diet. Okay, so diet, and he's also given an advice to do a exercise. Okay, so all these three he has been doing. So what has influence, what has got the more influence on this particular process here? Now this weight loss, I will call it as the yield here. Okay, to maximum yield, what I have to do it. Okay, so that's what we are going to study. Okay, this is about factorial design here. Okay, so now when there is a pill, see, he'll be having two things here. One is diet pill and another one is placebo. In diet, he is having a regimen. See, it's nothing but a plan. Okay, regimen is nothing but a plan of a diet. Okay, so plan of a diet, planned diet, I can call it as plan. Okay, then regular diet is having, then this is having a plan of exercise and regular exercise. So which helped him? I want to study whether the pill has got the direct this one, or the diet has helped him, or the exercise helped him. Okay, so now I'll call this as A, factor A. I'll call this as factor B. I'll call this as factor C. Whether A has got any influence, B has got any influence, or C has got any influence, I want to check it. Okay, it is a very big process. Now it is having two levels here. Okay, now I'll call it as higher level, lower level, for example here. So this is called level. Okay, these two are having levels here, levels here, levels here. So now we are having three factors here and two levels here. So we will be writing this as 2 cube. Okay, so therefore it is called as 2k factorial design here. So now what we are going to see here, now whether this A is having an influence, B is having an influence, or C is having influence, or A and B combined together is having an influence. That's what I'm saying. Otherwise, here I'm going to have B and C is having any influence on this. I'm going to check. So sometimes all the three is having any influence. That's also I'm going to check it. So many experiments I have to do it. It's not possible physically. So what I am doing is I'm using a factorial design. This is what is the general idea behind the factorial design here. Okay, so now we will see what is this in an example here. See, let us imagine that the researcher wants to find the effectiveness of a diet pill. Now this effectiveness of the diet pill is called the yield for us. Okay, so this is what is the yield we are going to measure it. So over a placebo, diet pill over a placebo, a dietary regimen B versus usual diet, and an exercise regimen C versus usual exercise on a weight loss lasting at least a year for an adult man. So now this is my scenario. So what I do here is, in this situation, a factorial design can be more efficient. Why I'm going to show here. See here, the researchers can study not only all the treatments separately. A is having influence, B is having influence, C is having influence. Otherwise, he just wanted to pairwise interaction, A, B together having an influence, or AC is influenced, or BC is influenced the weight loss, or also A, B, C all together will influence this weight loss or not. He just wanted to find out using an interaction. This is called the factorial design. So we will see how to go about using two factors only here. I'm not going to use any three factors here. I'm going to use two factors here. So we'll call it as 2 power 2 factorial design. Before that, I should understand what is called 2k factorial design. Why this 2 is coming? Why this k is coming? 2 means it is having two levels. Okay. So for example, high and low, for example. So from 5k, suppose I'm just influencing means 15% to 25%. I'm influencing. So this is the lower level. This is the higher level. So that's 2 level it is having. So I'm calling it as 2 here. How many factors we are having? That is denoted by k. So we can have 2 factors. So 2. So 3 factors 2 cube, 4 factors 2 power 4, etc. This is 2 levels. Okay, levels will be denoted by 2, and the power is always the factors you have to remember. Okay, so now we'll quickly move on to an example here. So how to, before that, we should find out what is called the terminologies we are using. Some definition like, so we just wanted to see, quickly move on to the terminology. What is the response variable? See, what we are going to measure, it is called the response variable. So for example, in our example previous, weight loss, okay, that's called the response variable here. The factors means independent variables. See here that the pill, okay, pill and the diet and the exercise in our example, which we have given previously, that's called the factors here. Okay, so now what are the levels here? Subdivision of factors, sometimes it is high and low. Here we are having a pill and a placebo, like that. Those are called the levels here. Okay, now main effect is nothing but simplest effect. I'm going to measure it, whether A is having a influence, B is having a influence, C is having influence. That's called the main effect here. Interaction means, see, there is a factor A, there is a factor B. Is there any interaction between these two, so that these two combined together will have a influence on the experiments? See, for example, outcome of the experiments. That's what I'm going to find out. That's called the interaction here. Okay, now what is called replication? See, I have done one experiment. Okay, so I have given a pill for him, I have given a diet for him, I have given an exercise for him for the first day. The same thing I'm going to give it for the second day, just adjusting these things. Okay, adjusting some levels of this, I'm going to give the same thing to him. So that's called the replication. It's nothing but the repeat. Okay, so how many times I'm repeating the same experiment, that's called the replication. We usually call it as rerun. Okay, rerun. Okay, same input levels here. Okay, now experiment designs specify the number of experiments, the factor level combinations, and the number of replications. This is called the experimental designs here. Okay, now what are all the types of factorial design we are going to have here? Quickly we move on. See, first one, simple thing, we can have it as a 4 types of factorial design. First one is called 2-level factorial design. This is what we are going to study today. Here we investigate the main effects of a few factors run at 2 levels each. Only we are having 2 levels. That's called 2-level factorial design. Blackett and Berman factorial designs. Here we investigate the main effects of a multiple factors. Okay, so at 2 levels each using few runs. Okay, now the next one is general full factorial. Investigate all effects. That's called the full factorial design. See, investigate the main effects of a multiple factors run at different number of levels. Then I'll call it as general full factorial design. Now the last one is Takuchi. Okay, so here we investigate the main effects of a multiple factors using a few runs. These 3. Okay, this is the first one, second one, third one. We are going to see in a different video, separate video, so that we can explain while we are doing this. For time being, we will be doing the 2-level factorial designs alone in this video. Okay, so whenever we do this, we have to keep it in one mind. So full factorial design means it is to tell all possible combinations. I'm going to take it in the full factorial design. Suppose I want to reduce, see, for example, see, 2 power k. Okay, so I want to reduce something here. That's called partial factorial design. Okay, so now subset of possible combination of factors. Here all the combinations I'm taking, here some subset of the combination I'm taking. So if I take all the combination, it is full factorial design. If I take the subset of this, it is the fractional factorial design. So we'll be doing a separate video for this also. So what is called a 2k factorial design here? Okay, so 2k factorial designs will have k factors, okay, of only 2 levels. There are 2 levels, 2 k factors, k, so we call it as 2k factorial design. So 2k factorial designs provide the smallest number of runs. So we'll be having a smallest number of runs, so it is easy for us to go for it, right? So 2k factorial designs provides the smallest number of runs with which k factors can be studied. Okay, it is repeated here. Okay, so now see, these designs are used very widely in industrial experimentation. Okay, that's what. So now this is what we will be doing here. It is 2 power 2 factorial design. How to conduct this experiment with an example here. Okay, now 2 power 2 factorial design will have two factors here. So we call it as two factors, two levels. Okay. So A and B will be our factors. It is having two levels here. Now the levels may be low and high. Okay, there are two levels. Low will be denoted by minus sign, high will be denoted by the plus sign. You have to keep it in mind. Okay, so now the treatment combinations, how to write this treatment combination. So we'll be writing it in the form of a tabular column. How I'm going to write. Now here this minus is low and B is also having low. Okay, low, low, then the treatment is called, see, within bracket, I have to put it 1. So it is called the notation. Okay, we have got a notation for this. I'm going to tell in this. Okay, now whenever there is, this is the high one, this is low. This is high, this is low. This is low, this is high. What is the meaning of this? Okay, so now when A is having a low level, B is also having the low level, I have to mark it as 1 here. Okay, this is called the Yards notation. See, what is this Yards notation is there? I'll tell you. So whenever both are low, this is low and this is low, I will mark it as 1. Here you see A is high. Okay, now A is high, then whichever is high will be denoted by the particular alphabet. See, A is high, it is denoted by A. B is high, it is denoted by B. A is also high, B is also high, it is denoted by AB. This is called Yards notation. This is very, very important. You have to keep it in mind. Whichever is high is denoted by the original alphabet. A is low, B is also low. So I am denoting it by 1. Then here A is high, so it is denoted by A. Then here B is high, so it is denoted by B. Here A and B both are high, so I am denoting it by AB. This is called Yards notation. That's what is given. You have to keep it in mind. So whenever we do this 2 factorial design, Yards notation will play a very important role here. Okay, now I'm going to estimate the main effect and interaction effect of the factors A, B, C, right? So to do this, the simple effect is calculated by this formula. Okay, I'm going to, so what is this? A, this is 1. This is taken from this Yards notation table. Okay, Yards notation table, we have to take it, all these values here. So now simple effect of A at high level of B is given by this. Low level of B is given by these two formulas. The main three formulas are given here. Okay, main effect of A is given by 1 by 2n into AB plus A minus B minus, this is not 1, this is taken from the table that you have to remember here. Okay, all these values AB, A, B and minus, this 1 is always taken from this Yards notation table. Okay, the next one, the main effect of B will be this formula. Same, just note down here, A is replaced by B, B is replaced by A. Now, I'm going to have the interaction between A and B that is given by this formula. Okay, now how to calculate using this one example we are going to see here. Okay, so what is that example here? Now, let us suppose that we want to study the increase in the yield of a chemical process. There is a chemical process which involves two factors. One is called the concentration. Concentration is 1. And which is having two levels. So from 15% to 25%, I can select any value. This 15% is the low level and 25% is the high level. Okay, it is having the two levels. So the researcher used to just adjust these to find out the maximum yield in the chemical process. Similarly, I'm going to have the another one way factor here that's called catalyst amount. I can call it as catalyst amount. This is concentration level and catalyst amount is B. So which is having 1 pound and 2 pounds. From 1 pound to 2 pound, I'm increasing. This is the lower level. This is the higher level. So here, how many factors are there? A and B, there are 2 factors. And how many levels are there? 2 levels. So we are calling it as 2 power 2 factorial here. So how to go about this? We are going to have these calculations here. We shall consider 3 replications. Replications, how many replications you want? You can have it. 5 replications, 7 replications. How many replications you want? You can have it. We are going to have 3 replications for this particular sum. Okay, this is a sum given. There are 2 factors given, 3 replications given. Okay, so now this is the value which has been given by the researcher. So this is the total output. He has got it. Okay, so now I want to write the Yards notation here. Okay, now this is low and low, so it is denoted by 1. See, A is high, so it is denoted by A. Then B is high here, denoted by B. Then both are high values, that is AB. So what is the meaning of this here is, see, whenever A and B is there, so here they have used 15%, here they have used 1 lab, okay, so 1 pound. Here they'll be using around 25%, here 1 lab. Here they'll be using 15%, and here 2 pounds. Here they'll be using 25% as well as 2 labs. Okay, that's what's the meaning for this particular thing. Okay, so now, right. So now here, see, this is the total is given. I have done a yards notation here. This particular thing, I want to show it as a graphical thing. Okay, so now how to show this as a graphical notation here? So this is what is the value given here. So this is 2 into 2. So I am having a square for this. Okay, so I'll draw a square for this. Now imagine here, A is low, B is low, then the value is 80 and it is denoted by 1. So I am going to have 2 axes here. Okay, so now in one axis, I'm going to keep it the factor A. In one axis, I'm going to keep this axis, I'm going to keep it B. So each will have the low and high value here. Okay, now this is the reaction concentration. Reaction concentration here it is 15%. Here it is higher values 25%. Here it is 1 pound. Here it is 2 pound. Okay, so that's what is the thing here. Now listen here. Now I have got both low. Okay, now A is also low. It is low here, and B is also low. It is denoted in this corner. Okay, some values will be denoted like this here, inside, inside, inside also. That's what we are going to study. Now where it will be shown here. Okay, now just see here. This first circle is called low for concentration A and low for concentration B. Low for A, low for A. What is the value is 80. 80, I'm showing it here. What is the yards notation is 1. The yards notation is 1. Okay, so how I got to this 80? I'm going to sum these. Okay, this is how the value is marked here. Now, when you go for this point, clearly you see A is the maximum. And what is B? B is the minimum. So where is A is maximum? A is maximum. B is minimum. That is 100. That should be shown here. Okay, that should be shown here as 100. Now go for this. Now A is minimum. So where is A? A is here. Where is minimum? Minimum is here. I'll put my circle here. Then where is B here? B. Okay, so now B is the maximum. B will be maximum. So my point will come here. So B is maximum. So my point comes there. Okay, right. Now here is 1 point as well as here is 1 point. Okay, B is 60. So where from this B is 60? So now my factor A is minus. So my factor A minus is here. Then I'll move on this to have the positive value. So therefore 60 is coming. Here, when I come here, this is also maximum. Okay, so now this A is maximum and it goes on here. This is also maximum. So I'll get the value as 90 here. Okay, from this table, this is how we'll have to draw this, the graphical notation. Whenever a table is given, it's fine. Otherwise, the graphical notation is given. This graphical notation has to be converted into this tabular column to write this yards notation and finish it off. It is easy. Now we are going to calculate the effect estimate for this. How to calculate effect estimate? See now, carefully note it down here. I'm going to have this value as 80. I'm having this value as 100. I'm going to have the value as B as 60. This is A, B as 90. I'm going to use it in the formula. Say this is from the previous table. I got it. N is equal to 3 because 3 replicates have come. So I'm going to calculate using the formula. It is very easy. See, main effect A is equal to 1 by 2n into AB. I got the value AB as 90. A is 100. B is 60. And see, this 1, I'm going to have it as 80. I'm going to substitute this value. Yeah, so I'm going to have this 8.33. Similarly, I am calculating for B. This is the formula. I'm going to substitute the values here. I got it as minus 5.00, right? So then I'm going for the interaction. What is the interaction formula? 1 by 2n into AB plus 1 minus A minus B. From here, from the previous table, I substitute the value, I got this 3 value. Now, what do I do from this calculating effect of estimates? I have calculated what do these values tell us. Okay, so I got 3 values. I'm going to tabulate in the next slide. You see here, practical interpretation. From this, what is the interpretation I'm going to give? Okay, main effect A came 8.33. So A is taken from, see, you clearly know it is high. Okay, now it is taken from high only. Then only I'll get A, right? So now it tells increasing the reactant concentration, because A is my reactant concentration factor. That's what I have taken. So increasing the reactant concentration, increase the yield. That's the interpretation I'm going to give. So what is the interpretation? I'm got it from this here. B is nothing but, see, it is giving a -1. B is a factor which is catalyst. So catalyst effect is negative for me. That's what I have sent. Now, what about the interaction now? Interaction effect is 1.67. It is very less compared to this. So what I'm going to say is interactive effect is relatively small. Okay, that is the interpretation I make from this experiment. Now, what I'm going to do is here, I'm going to construct an ANOVA table for my statistical calculations here. Okay, otherwise statistical inference also will be done using an ANOVA. So what do I do in an ANOVA table? Suppose if you don't know how to calculate ANOVA, we have done a video in our channel. Just visit and see how to conduct one-way and two-way ANOVA. Then come back. It will be easy for you to understand. Anyway, we are going to explain this ANOVA here. So now, statistical testing using ANOVA, we are going to calculate all these values here. I'm going to calculate SSA. I'm going to calculate SSB. I'm going to calculate SSAB. And I'm going to calculate SSE from these two values. Okay, now this is the total. When I subtract all these three things, I will get this SSE. Okay, so that's what we are going to do here. Okay, now make a note of this ANOVA table here. This is what we are going to calculate. So how to calculate this SSA? Is there a formula for this? Yes, of course. Statistical testing using ANOVA. We have got A is equal to 100, B is equal to 60, AB is equal to 91. This is low effect. Okay, we can have it as low. Right now, N is equal to 3 replicates. Here, I'm going to substitute in this formula. Now, SSA is given by, just note on this 4 here. It is not 2, it is 4. We have to use this formula with a square. So I am getting this value. So after calculating, substitute the value of AB, A, B, and 1, square it, divide by 12, because N is equal to 3 for me. So 4 into 3 is 12, 50 square by 12, which gives me 208.33. This is what this 208.33 only I'm going to substitute in this particular place. Okay, so in this particular place, 208.33 only I'm going to substitute in the ANOVA table. That's what you have to remember here. Okay, right. So what will be the next one? Similarly, SSB also I'm calculating, which comes around 75. SSAB I'm calculating. This comes around 8.33. Okay, so now all these three values I'm going to substitute in the ANOVA table here. Now total sum of squares, as you know, it is nothing but the SST. Okay, so it will be calculated using the tabular column. This I'm going to show it in the next slide. 323. Then this SSE, just from total, this is 323, right? 323. I'm subtracting SSA, SSB, SSAB. Then I'll get 31.34. These values I am posting it in a ANOVA table here. Now, what is the decision rule here? This is the decision rule we know clearly in our hypothesis testing. Hypothesis testing, calculated value is greater than the critical value, then reject. Okay, otherwise don't reject. That's what's that. So this is the degrees of freedom given. This value should be taken from F table. That you have to keep it in mind. Okay, now this is the decision rule. See, if you do not know how to calculate the null hypothesis and all, we have done a video for hypothesis testing. Just visit our channel to find out the hypothesis testing so that you will understand this. We have done so many videos regarding this. You can see. Now this is the decision rule. So I'm going to make all the values. This is SSA, SSB. This is SSA. This is SSB. This is SSAB. This is SSE. Now this is SST. Okay, how this SST has come? I'm going to total all these values. It has come. Okay, now how this 31.34 has come from 323? These values, I have add all these values, I have subtracting from this one. Okay, okay, now this 323 minus these, all this value, I'm going to add it and subtract it. So I'll get 31.34. That's what is given in the previous slide. So now degrees of freedom, always it is nothing but 2 minus 1, 2 minus 1, 2 minus 1. Here this is nothing but 4 into n minus 1 is 8. Okay, so now how it is coming? 4 into n is 3, so 3 minus 1 is 2, 2 into 4 is 8. That's how I got this degrees of freedom. Now this 11, how it has come? 4 n minus 1 it should come, I think. Yes, previously. I'm going to show this in the ANOVA table. You can see here. Okay, right. Now this is 4n minus 1. Just now, that 4n minus 1, you should get it. Okay, so now, now what I'm going to do it here, see this mean square, it is nothing but this particular thing. Okay, this divided by this, which gives you this column. Okay, now this divided by this is nothing but SSA, this is nothing but SSB, this is nothing but SSAB, this is nothing but SST. Here this is nothing but SSA divided by degrees of freedom, that is 1. Here it is SSB divided by 1. Okay, this is it. Okay, now this is nothing but SSAB divided by degrees of freedom is 1. Here this is SST divided by 8. Okay, that's what is calculated. Now this is nothing but MSA, MSA and MSB and MSAB. Okay, so I'm going to just substitute all these values. See, if you do not know how to calculate ANOVA, you can visit our channel to find it out. So once this F calculated value is there, I'm going to find out the F critical value from the table, and I'm going to compare this. Now here you compare it, calculated value is 53.15, so reject it. Here reject it. Okay, so now 2.13, which is not there, so it is the lesser value, so we fail to reject this. Okay, so now this is having an interaction, this is having interaction. Sometimes F critical value will be using P value also. Okay, now it is less than 0.05, which should come. So sometimes P also will be calculated. This is how we will use ANOVA table to find out to find out is there any interaction with the yield for A, B and AB, and we'll be using ANOVA to do it. So in our next video, we are going to use this factorial design using regression model also. Okay, I hope you understood this. If you have any doubt, kindly post it in the comment box. If you have not subscribed to our channel, kindly do it. Thank you very much for watching this video. Have a nice day.